Lightweight design and high-strength materials have gained wide popularity in the past years to reduce weight and improve the crashworthiness of passenger cars. The application of advanced high-strength steel is less utilized in trucks and buses, but there is a great weight reduction potential in exchanging traditional steel grades with advanced high-strength steel also in heavy-duty vehicles. In this context, weight reduction in the truck and bus sector is a crucial pillar to reduce greenhouse gas emissions. For this purpose, adequate knowledge of material properties, design techniques, and truck loading situations during service is required.
From Scania and CTM Eurecat, we centered our efforts in an innovative methodology to achieve the weight reduction in fatigue dimensioned components by shift to high-strength steel. For this reason, the aim of my work is to test 3 steel grades under alternative bending fatigue, in order to reproduce the real track conditions. The results obtained in this project will enable a lightweight design of track components.
By using advanced high-strength steel in trucks, the weight can be reduced. As a result of this, the payload is increased, which raises the transport efficiency. In addition, the environmental impact decreases because greenhouse gas emissions are lower for the same amount of transported goods.
A successful lightweighting in trucks is possible through recyclable materials as steel, combined with clever designs and innovative steel forming operations in which we have a deep expertise. High-strength steel can satisfy the severe loading situations such as fatigue, stability, elastic behavior, and ultimate strength. Fatigue at low stresses has a huge impact on high-strength steel. For this reason, it's necessary to deepen in all the aspects that can improve the fatigue strength.
The research has consisted of a series of studies and tests focused on a set of characteristics and properties. Fatigue is a phenomenon that defines how the cracks are formed and grow through the material under cyclic loads. It is highly influenced by surface effects, in this case located on the trim edge. The trim edge is characterized by a typical shape that can be improved with a correct trimming clearance and secondary operations such as blasting operation. The blasting operation introduces residual compressive stresses, reduces the surface effects and also the roughness value. The fatigue strength is also influenced by the material microstructure. Due to, as thinner is the microstructure, more cycles are needed to make the crack propagate.
In our laboratories, we carefully prepared and tested the specimens of 3 steel grades at 4-point bending fatigue to evaluate how the combination of all of these parameters can affect the fatigue performance of high-strength steels. After the test, an accurate study of fatigue fractures by scanning electron microscopy leads us to understand the edge behavior under bending fatigue conditions.
The results obtained by CTM Eurecat jointly with Scania from all the tests mentioned before allow us to state that using higher steel strength, the fatigue limit is increased in 62% compared with lowest steel grade under the same edge conditions. Fatigue life is highly influenced by stress ratio, and blasting process improves the edge quality and fatigue strength in at least 10%.
This work shows the wide potential of advanced high-strength steels in heavy-duty vehicles. Also shows the huge importance to give to these steels the optimal performance to satisfy all the requirements. In my opinion, a close work between steel makers, research institutes and truck manufacturers can achieve a high knowledge necessary to develop new steels and new steel forming operations to produce a safer, lighter and stronger truck. Therefore, the utilization of this renewable material is the way to make the transport industry more environmentally friendly. Finally, I would like to thank to my supervisor Daniel Casellas from CTM Eurecat and Kaisa Hamburg and Henrik Siorin from Scania to give me the opportunity to do this work, and also to all the staff from CTM Eurecat, Scania and UPC to always help me and teach me.